Hello people, this is Shanmugam. Welcome to my YouTube channel. Today we have an exciting topic to be discussed. One of my favorites, real-time bus monitoring information system. Come on, let's get into our topic without any further delay. What this system really does is, it keeps on track the bus current location and gives the data to the microcontroller, and microcontroller will display it on the LCD. So the passengers can view the bus location. The next. The objective of this project is to display the real-time location of the buses in the metropolitan cities. This system will enable the tracking device to obtain GPS data of the bus locations, which will then be transferred to a centralized control unit by using GSM and then transmitted to a bus stop and displayed on the LCD. Social relevance of this project is it ensures the passengers to locate the bus so that they can prepare themselves whether to wait for the bus or to travel by any modes of transportation, which allows them to plan accordingly to their time constraints. Bill of materials. These are the cost of making this project. 8051 microcontroller cost ₹89, PCB board cost ₹99, Neo GSM GPS module cost $699, and Wi-Fi module cost $120, LCD display cost around $90. So the total cost of this project is around $1097. Let's discuss about the GPS module. It has a transmitter and receiver pin, which is TX pin and PX pin. The data is sent bit by bit from GPS module to the Arduino board or any other kind of microcontroller. We are using 8051 microcontroller for our project. The GPS module sends the data through TX pin and the microcontroller receives through its RX pin. Here logic 0 means 0 volt and logic 1 means 5 volts. This is how it works. Here I have collected the data from GPS module. These are the data which will be sent to the microcontroller from GPS module. We will have several data which will be starting from dollar symbol like GPVTG, GPGGA, GPGSA, GPRMC, GPVTG, GPGGA. We only need the data of which is starting from GPGGA, since that only has the longitude and latitude data. We need to filter out it from others, which I have written below here. The value I have highlighted is the longitude value and the latitude value. Here N here represents the north and E represents the east. Come on, let's get into the most interesting part of our project, the backbone of our project, the coding of 8051 microcontroller, which I have coded in the Keil software. This is the code for our microcontroller project. The first 15 lines of the code are initialization of the functions and characters which we have used below. Let's move on to the main function. I have used tmod as 0x20, which is timer 1 mode to auto reload mode, and th1 is equal to 0xFD, setting the baud rate as 9600 and giving the SCON value as 50, 8-bit data, 1 start bit and 1 stop bit. So I'm starting the tr1 is equal to 1, which means I'm starting the timer. LCD init function, which displays the LCD messages that says hello all, and after delay it prints the message welcome to my project. This while one, it keeps on running. After entering this while loop, the LCD will display waiting for GPS connection. When the data is received, the RA flag will turns on and it moves to this if condition. If sbuff not equal to $, it says that go to loop. look into here. Our GPS value always starts from dollar. So if the given data is not dollar, it keeps on going into the loop and checks whether the given data is dollar or not. If the given data is a dollar, then it directly goes to this for loop. We have set this I limit as 50 since the GPGGA, this whole data contains 50 characters. So we have set it as 50. And if the value RI flag turns on, it moves the code to here, this line. The AI copies the value of sbuff, and the next step is the first step we check whether the code starts with dollar, and again second step is to check whether the code starts with GPGGA. If it starts with GPGGA, it prints GPS module connected, and after a delay we have set I is equal to 17. Why we should set I is equal to 17? Let's see. Since we only need this longitude value 09589655, which starts after 17 characters. So we are going to start here 17. So we are setting I value as 17. We don't need these all values. Only we need the longitude value which starts after 17 characters. So we are setting I is equal to 17. And the total value of that longitude is 9, so we are setting the limit of j as 9, and the array copies the value to ln of j, and every value copies to it. After once the j value goes to 9, the for loop comes out and the ln of j equal to null. The 10th character copies as null character. Since to represent it as string, we are keeping the last character as null. Similarly, for latitude value, the character starts after 29, so we are keeping I as 29. The same process does, and the value copies to the latitude array. Similarly, after the display starts printing the value of longitude and latitude. This is the line which prints the latitude value and longitude value. So that's all here with the code of our 8051 microcontroller. So we are in the final stage of our project, that is simulation, which I have done in the Proteus software. The real fun part of our project is this. I have built the code in Keil and converted it into a X file and uploaded the code to the microcontroller. Now it is ready for simulation. Since we don't have GPS, I will be giving the exact data of GPS manually to the virtual terminal. If in real the GPS data is connected, it currently sent to the virtual terminal. Let me show the working of it. Let me run this. Here pop-ups the virtual terminal. Let me go to this data and copy it and paste it over here. See, look, GPS model connected the displays, and it displays the value of the longitude and latitude. This is how it works. If we paste some other value, the LCD will display the error message. So once again we will get into our code. If the data doesn't start with GPGGA, the code will not get into this if statement. It directly comes to this clear statements and clears all the timer, everything, and sets I is equal to 0. And once again it goes back to this while statement to check the initial conditions, whether the given message is starting from $. It continuously repeats the process. So this is how this project works. Thanks for watching. Thanks for watching the video, guys. If you have any doubts or queries, please comment in the comment section below. I will reply it. Thank you, people.